So domain and range is a little extra added in some information between 5.4 and 5.5 because you need to know this information for 5.5. It's a little bit of a complicated idea, although the information laid out here hopefully will alleviate a little bit of that complication. So domain and range, we know already, are all the possible values for x and y, or dependent or independent, or the horizontal or vertical information when we do a graph. When we move into the next or the coming units, we're specifically going to talk about or start talking about linear equations, in which we may have something that looks like this: y is equal to 3x plus 3. Well, all of our domain values are our input values, the values that we can put in for x, which is our domain, or our independent variable. All of those values we can put into that situation to get our range values, or our dependent variables, or our y-axis. Okay, so it's important to remember that that's kind of where we're going from there. Now, the biggest or the main idea of this section, added section, is to be able to write out domain and range in a simpler way and have it be kind of continuous from one person to the next in what everything means. So do your best. If you have questions, please ask. Okay? Given the graph of any kind of function, so we're given a number of different graphs and we're asked to determine what the domain and range are. The domain, okay, remember the domain is the set of x values. What numbers can we put into that to get out a y value? So it's the set of all the possible input numbers. And you can think, a little phrase that helps: at what point does the curve of the graph stop from left to right? Or is it continuous? So when we're talking about domain and range, for domain, we're talking about what the graph does moving from left to right. This way, left to right. Okay, we're not worried about up and down, just left and right. The range values are the other ones. Okay? They're all the possible output values for whatever the situation happens to be. And then you can think to yourself, well, the range is what does it do from top to bottom? Vertically, what's the graph doing up and down? Not necessarily left and right, but up and down. So you look for maximum or minimum points is what we call those. Okay, so let's look at some examples. And there's two types. There's continuous and non-continuous. Then I find the non-continuous ones a little easier to do. The continuous ones a little bit confusing. Okay, so if we just look at number one here, okay, if we're given this graph, if we were to start indicating or defining points on this graph, this point would have values or coordinate points of 1, -2. This point would have coordinate values of 4, -2. And we could go the other side. We could go -2, -2, and further -4, -2. And we could continue to list out millions of different points. All of these points have coordinate axes, or coordinate values. Okay. Now, let's look at what this graph does for the domain values only. Just what its possible x values can be. And you think to yourself, well, can x be 2? Well, here's x of 2 is right here. Does it cross the graph? Sure. Can it be 3? Yeah. Can it be 4 or 5 out here? Yes. Can it be 6, 7, or 8, which is off the graph, but can it be here? It can be, because this arrow here indicates that this goes on forever. Can that be 1,000,000 way out here? 1,000,000? Sure it can. In fact, it can be everything up to there. And if we start looking in the negative direction, can it be -1? Well, x of -1 was right here, and yes, it crosses the line. Can it be -5? Yeah, crosses the line. Can it be -10 way out here? Sure, crosses the line. It's not on the graph, but this arrow here again indicates that this goes on forever this way. And in fact, it can be infinity negative and it can be infinity positive. But we don't want to have to write that, so we write something a little bit more abbreviated. We just say that x is domain, is all real numbers. Because x can be anything, because this graph is continuous in both left and right ways. Okay. Now there's a couple of ways we can see this phrase be written. We could also write x's domain is all real numbers. So that's a fancy symbol. It's like a double-backed capital R. Or you might see x's domain, this fancy rounded E, is all real numbers. All means the same thing. Now, if we look at just the range values now, okay, so actually back to the domain values, if you see on our graph, in our list of coordinate points here, our ordered pairs, -4, -2, 1, 4, what values can these have? Well, these values for any ordered pair on this graph can be anything. Again, all real numbers. Okay, so just another way to look at that to get an answer for domain and range. Now, if we look at range values, what are the possible y values that this equation can have? Well, this equation doesn't move, or this graph doesn't move anywhere except for right there. And this y value is -2. And you can see that from our list of ordered pairs. -2, -2, -2, -2. Can this graph have any other y value of -2? No, it can't. So our range is y can only be -2. And that's simply put as our range. Okay, so I'll do example 2 with this video, and then I'll jump over and start a new video for 3 and 4, and then 5 and 6 again. So there's example 1. Example 2, again, we have a continuous graph. We have a continuous graph because we have these fancy arrows on the end. Okay, so it's continuous. Okay, that's what it means. And we look. So if we started listing out coordinate points, you could get a coordinate point here. Whoops. Here. Nice little one to label. This one here. This one here. Now, if we listed out those coordinate points, we'd get values. And even in here, there'd be an ugly value, but it would be a value. Looking at the domain, or the x values only, okay, can this graph have a value of x equal to 0? Sure, crosses the graph right there. How about 2? Sure, crosses the graph right there. 3, 4, 5, there's 4, there's 5. Can it be 10? Way out here, 10? Sure, it's eventually going to cross the graph. Can it be 1,000,000? Yes, it can. It's just not on the graph. Can we go negative the same way? Well, there's -2. Can it be -3? Yeah, it crosses the graph right there. -4, right there. -5, yeah, right there. How about -8? Way out here. Sure, the graph will come out here. It'll eventually touch and it'll cross right there. Again, it can go negative that way as well. So here, again, because we can have all values positive and all values negative, x's domain is all real numbers. Or again, x's domain is all real numbers, or all real numbers. And you can say that for domain and or range. Okay, and I'll show you in a quick second here. So now that's our domain. We look at our range. What y values are possible? Can we have a y value of 0? Sure, crosses the graph right there. How about 1? Yep, right there. 2, right there. 3, 4. Oh, 4 doesn't cross our graph there, but if we extended it, because this is continuous, it eventually would. Can it be 1,000,000 way up here? Sure it can. How about negatively? Down here. Whoops. Down here. -1. Yes. -2. Sure. It's right off the graph a little bit, but it'll cross. -5. Way down here. Or 6, whatever that is. -6. Sure. It would cross the graph, but way out here somewhere. And again, can it be -1,000,000? Yes, it would eventually get there. So this graph continues on both negative and positive directions for the y-axis also. So again, I can say y's range is all real numbers. or y's range is all real numbers. Either or, whoops, I don't want to do that, that's backwards actually. All real numbers, double back r here, single back r here, or y is all real numbers. Okay? Same thing.